Imagine, for a single moment, that you are standing in the exact geographic center of a continent. You are looking at a structure so incomprehensibly massive that its physical presence has fundamentally altered the mechanics of the planet you are standing on. This is not a theoretical construct or a concept pulled from science fiction. This is the Three Gorges Dam, a $31.7 billion scar carved across the belly of China, a 2,309-meter block of concrete and steel that represents the absolute pinnacle and the absolute terror of human engineering. We do not often pause to consider what it means to tame a force of nature, because as a species, we have rarely succeeded. But here, at the edge of the Yangtze River, we did not just succeed. We choked the third longest river on Earth into submission, and in doing so, we literally shifted the mass of the world. You are about to step into a real-time infrastructure dossier, a raw deconstruction of an anomaly that displaced 42 trillion liters of water, generating enough continuous electricity to power a nation, while simultaneously extending the length of your day by a measurable fraction of a microsecond. This is the story of what happens when humanity decides it no longer wants to adapt to the Earth, but wants the Earth to adapt to it. To understand the sheer audacity of the Three Gorges Dam, you first have to understand the enemy it was built to destroy. The Yangtze River is not just a body of water, it is a roaming behemoth. Stretching over 6,000 kilometers from the glaciers of the Qinghai Tibet Plateau to the East China Sea, it has served as the lifeblood of Chinese civilization for millennia. But it has also served as its most devastating executioner. Historical records stretch back thousands of years, chronicling floods that would swallow entire cities whole, leaving behind nothing but bloated wreckage and starvation. In the 20th century alone, catastrophic floods in 1931, 1935, and 1954 killed millions of people. The river was a sleeping dragon, and every spring, when the snows melted and the monsoon rains crashed down from the sky, that dragon would wake up in a fury. The political will to build a dam at the Three Gorges, a treacherous, incredibly narrow canyon in the middle reaches of the river, had existed since the early days of the 20th century, envisioned by Sun Yat-sen and later championed by Mao Zedong. But the technology, the capital, and the sheer geological understanding required to pull it off simply did not exist. It would take until the late 20th century for the blueprint to finally become a reality, and when it did, the engineers were not just planning to build a wall, they were planning to perform a geological lobotomy on a continent. The first phase of this operation was so extreme it borders on the absurd. You cannot simply pour concrete into the third longest river on Earth and hope for the best. You have to kill the river first. This meant diverting the entire flow of the Yangtze away from the construction site. Imagine trying to redirect the blood flow of a living giant without killing it. Engineers had to carve massive diversion channels into the solid rock of the riverbanks, creating a temporary bypass for the water. Once the channels were ready, cofferdams, massive temporary enclosures made of earth and rock, were constructed in the main riverbed. Then, the water was forced into the channels, exposing a section of the riverbed that had not seen the light of day for millions of years. The mud was deep, treacherous, and unstable, but beneath it lay the only thing that could support the weight of what was coming: solid, unyielding granite. The engineers had mapped the geological faults beneath the riverbed with intense precision, knowing that placing a billions-of-ton structure on a weak point would result in a catastrophic failure. They found their anchor in the crystalline bedrock of the Yangtze Craton, a piece of ancient continental crust that was incredibly dense and stable. Then came the concrete. When we talk about the concrete used in the Three Gorges Dam, we are not talking about the material used to pour a backyard patio. We are talking about 28 million cubic meters of a specially engineered, heavily reinforced compound. If you were to take that amount of concrete and turn it into a 1-meter-wide sidewalk, it would wrap around the entire planet at the equator. The logistics of mixing and pouring this material were a logistical nightmare that lasted for over a decade. Standard concrete generates heat as it cures, a chemical reaction known as hydration. If you pour a massive block of standard concrete, the core will heat up so intensely that it will expand, crack, and destroy itself from the inside out. To prevent the dam from literally cooking itself to death, engineers had to pipe millions of gallons of cold water through a vast, hidden vascular system of pipes embedded inside the concrete. They also used low-heat cement mixtures and crushed the aggregate, the rocks and sand, into perfectly calibrated sizes to minimize the spaces between them. Layer by layer, meter by meter, the dam rose from the bedrock. Thousands of workers operated in brutal conditions, enduring stifling heat, deafening noise, and the constant, looming threat of the river fighting its way back into the canyon. They were essentially building a mountain in reverse, taking processed earth and stacking it into a perfectly geometric barrier designed to hold back the sky. Once the wall was complete, the engineers had to address the second piece of the blueprint, the turbine matrix. A dam of this magnitude is not just a barrier. It is an immense machine designed to convert the raw, destructive kinetic energy of falling water into the lifeblood of modern civilization, electricity. But you cannot simply attach a generator to the side of a 200-meter-tall wall. The mechanics required to harness 22,500 megawatts of continuous power had to be housed deep underground, hidden within the very guts of the mountain itself. To access this subterranean world, engineers had to blast and excavate massive caverns out of the granite on the southern bank of the river. These are not small rooms. They are cathedral-sized voids carved into the earth, large enough to comfortably fit a Boeing 747 inside them. It is a dark, echoing labyrinth of reinforced tunnels, giant shafts, and pressurized pipelines that stretch for kilometers. Down in this artificial underworld sits the turbine matrix, 32 massive hydroelectric units, each one a masterpiece of heavy engineering. These are primarily Francis turbines, a design named after James Bacino Francis, but scaled up to sizes that would have been unimaginable to the man who invented them. Each turbine weighs hundreds of tons and features a runner, the spinning part of the turbine, that is over 9 meters in diameter. The mechanics behind their operation are a masterclass in fluid dynamics. When the dam's operators open the massive intake gates high up on the reservoir, billions of liters of water begin a plunging descent. By the time this water reaches the turbines deep underground, it is traveling under immense pressure, funneled through giant steel penstocks that narrow to increase the water's velocity. The water slams into the curved blades of the runner with the force of a speeding freight train. Because of the precise angle of the blades, the water is forced to spin inward and downward, causing the massive steel runner to rotate. This rotation is then transferred to a giant vertical shaft, which connects directly to the generator sitting just above the turbine. Inside the generator, massive electromagnets spin within a coil of copper wire, and through the fundamental principles of electromagnetic induction discovered by Michael Faraday, the physical movement is converted into a continuous, pulsing stream of alternating current. The water, having surrendered its kinetic energy, is expelled out the other side of the turbine through a draft tube and sent back into the river below the dam. It is a violent, deafening process happening in total darkness, yet it yields absolute silence at the end of the line, the quiet hum of a power grid being fed. 22,500 megawatts is enough power to keep the lights on, the factories running, and the air conditioners humming for tens of millions of people. It is the heartbeat of the Chinese industrial machine, extracted silently from the crushing weight of a river. But all of this, the taming of the river, the 28 million cubic meters of concrete, the subterranean turbine matrix, is merely the prologue to the true anomaly of the Three Gorges Dam. To understand the final, most mind-bending aspect of this structure, you have to look past the engineering and look directly at the hard physics of the planet itself. When the floodgates were finally closed and the river began to back up, it created an artificial reservoir that stretches over 600 kilometers upstream. This is not a lake. It is an inland sea, dropping 42 trillion liters of water into a basin that was once dry land. We have a tendency to view water as weightless in our daily lives. We splash it, we drink it, it flows easily around us. But water is incredibly heavy. A single liter weighs exactly 1 kilogram. When you multiply that by 42 trillion, you are looking at 42 billion metric tons of mass. This is the equivalent of taking 300 Great Pyramids of Giza and dropping them into a single geographic region. The hard physics of this planetary anomaly rely on a concept known as the moment of inertia. Imagine a figure skater spinning on the ice with their arms pulled tightly against their chest. They are spinning incredibly fast. But when the skater extends their arms outward, their mass is distributed further away from the center of their body, and their rate of spin slows down. The Earth operates on the exact same principle. Our planet is not a perfect sphere. It is an oblate spheroid, spinning on its axis once every 24 hours. Because the reservoir of the Three Gorges Dam is located at a specific latitude roughly 30 degrees north of the equator, the 42 billion tons of water are being held at a distance further from the Earth's axis of rotation than the ocean water that would normally be there. By holding all that extra mass further away from the center of the spin, the Earth, like the figure skater extending their arms, has to slow down its rotation to conserve angular momentum. The math behind this is indisputable. The sheer weight of this artificial reservoir has slowed the Earth's rotation. It is a barely perceptible change, measured at 0.06 microseconds, but it is a real, physical alteration to the mechanics of the planet. Every single day that passes is now 0.06 microseconds longer than it would have been if the dam had never been built. We, as a species, reached down and put our finger on the cosmic dial of time, and we turned it, just a fraction. And the manipulation of the planet's mass did not stop at the rotation. When you place 42 billion tons of water onto a continental plate, the sheer weight of it causes the crust to compress. Seismologists closely monitor the area around the Three Gorges Dam because of a phenomenon known as reservoir-induced seismicity. The immense pressure of the water seeps into the microfractures and faults beneath the valley, acting as a lubricant, and the physical weight of the water pushes down on the tectonic plates. This combination has triggered thousands of minor earthquakes in the region since the reservoir filled. The Earth is literally groaning under the weight of our ambition, adjusting its crust to accommodate the artificial sea we dropped onto its surface. The dam altered local microclimates, trapping moisture and changing the temperature gradients of the valley. It stopped the natural flow of sediment that had traveled down the Yangtze for millions of years, starving the delta downstream and causing coastal erosion that is reshaping the geography of the East China Sea. The ripple effects of this $31.7 billion blueprint are still propagating outward, interacting with the planet's systems in ways we are only just beginning to understand. Yet, to stand at the edge of the Three Gorges Dam today is to feel nothing but absolute stillness. The violent explosions of granite, the deafening roar of the diverted river, the endless parade of dump trucks pouring concrete, all of it is gone. In its place is a wall of concrete so thick that it feels permanent, a monolithic shield standing guard against the chaotic entropy of nature. The ship locks, towering staircases for ocean-going freighters, lift massive vessels up and over the wall in a slow, deliberate ballet of buoyancy. The water on the upstream side sits flat and glass-like, an eerie, perfect mirror reflecting the steep, green walls of the gorges. There is no sound of rushing water. The turbines are buried too deep underground for their roars to reach the surface. It presents a facade of total control, a triumph of the human mind over the blind, destructive forces of the natural world. But that stillness is an illusion. Beneath the surface, the water is straining against the concrete. The turbines are spinning in the dark. The tectonic plates are shifting under the immense new weight, and the Earth itself is spinning just a fraction of a second slower. The Three Gorges Dam is not just a structure. It is a dividing line in the history of our species. Before it, we built our cities around nature, praying the river would not flood, praying the Earth would not shake. After it, we proved that we possessed the capital, the computational power, and the raw, audacious will to rewrite the geological and physical rules of a continent. It displaced over 1 million people, submerged entire cities, and forever changed the ecology of a river that has flowed since the dinosaurs. It is a monument to human hubris, and simultaneously, a monument to human brilliance. We looked at a wild, untamable force of nature, and we did not back down. We drew up a blueprint. We poured 28 million cubic meters of concrete into a solid granite foundation. We buried a matrix of 32 turbines deep in the earth, and we held back the sky. And in the end, the structure we built was so profoundly heavy, so relentlessly massive, that it reached out into the vacuum of space, and touched the very spin of the planet. The dragon is caged, the lights are on, and the day is just a little bit longer than it used to be.